Okay, ladies and gentlemen, all right, before we get started today, we got a couple of things that you need to have. You should have a glue stick, scissors at some point during the lesson, so if you need to borrow at some point during the lesson, you can do that from your neighbor. You need your pencil. You need the parts of an algebraic expression sheet. You also need this little flip book, and you should have been given highlighters at your table. You're going to need 3 of them of different colors. So let me remind you that as we do this video, if you need to pause at any point to stay with me, please pause the video and then you can push play to begin it again. The first thing we're going to start off with is I would like for us to look at this small little sheet right here that says parts of an algebraic expression. Well, first off, let's talk about our essential question. Our essential question for today is, how can you identify and write equivalent expressions? Remember, an expression is a numerical sentence that does not have an equal sign. Remember that the word equivalent is basically another word for saying equal. So what we're going to do today is we want to be able to identify parts of an expression because these are all expressions here. Well, the first thing, we got a couple of vocabulary words. The first one is terms. Well, the parts of an expression that are separated by a plus or a minus sign are all terms. So for example, 12 is a term. Now this is a positive. 3y squared is a term. Positive x or 4x is a term. Positive 2xy and positive 4, okay? So we're saying all of these that are separated by your plus or your minus signs, okay? We're saying that those are all terms. So we're saying that a term can have a variable connected to it. It can have an exponent connected to it. All of those are considered terms. Now, a coefficient are numbers that are multiplied by at least one variable. Well, that sounds kind of confusing, but truly a coefficient is a number that is smashed up against a variable. So in this problem, this one, 3 is a coefficient because it is smashed up against a y. 4 is a coefficient because it's smashed up against the x. 2 is a coefficient because it is smashed up against a y squared. Now 12 and 4 are not coefficients because they are not smashed up right up against a variable. They're not connected. Now like terms, okay, which I'll go ahead and tell you that a 12 and 4 are called constants because 12 is always 12. It doesn't change. It's that value no matter what. So those are actually known, 12 and 4 are known as constants because their value never changes. 4 is always 4. Any way you look at it, 4 is 4. Now like terms are terms that have the same variable raised to the same power. So in this problem, we have 12 and 4 are actually like terms because neither one of them have a variable that's connected to them. What I like to say when we talk about like terms is their last name. So for example, 12 and 4, they don't really have a last name. Like my name is Kristen Musgrove. Well, Musgrove is my last name. So the people who are in my family, their last names are Musgrove. In this instance, we have 3y squared. Well, 3y squared and 2y squared. Y squared are their last names. So they are like terms. They are the same. The only thing that's different is that there is a 3 in front and the other one has a 2 in front. It's kind of like my children, Bristol Musgrove and Lane Musgrove. They are family. Bristol has a different first name than my son Lane, but they're both in the same family because their last names are Musgrove. So think about the variables in that way, that y squared is its last name. In this one's different. X is its last name. So 4x is its last name, or X is its last name. 4 is its first name, X is its last name. Now, I want us to move on to this little booklet, and we're going to go into a little bit deeper of the like terms. Yes, like terms or creating the like terms can be somewhat confusing, but we're going to do a good bit of practice. But the first thing I want us to do is I want us to get out our little booklet here. You can set this to the side. We'll glue this in our notebook in just a minute. So you have your notebook here, and again, you want to use it just like a normal book. So using one of your highlighters, you can write on the front, combining like terms. Now we're going to open it up. Again, pause the video at any time. If you get behind, it's okay. So open your book and pull out your pencil. So with our pencil over here on the left, we're going to write a few notes. Don't write really, really big, because if you write really big, you're not going to get everything that we need in here. We're going to have about four sets of things that's going to go in here, so I'm going to need you to not write huge. So, to combine like terms. Number 1. Draw lines in front of each plus or minus to separate the terms. Number 2. You want to color all the like terms the same color. Number 3. Put each group of like terms together. Number 4. Simplify each group into one single term. Now here's something we need to add, a little star. Must have same variable and power to combine. So just like we talked about a while ago, you have to have the same variable and power to combine. So if we have a y squared, it can only be paired with y squareds. I cannot put a y squared with a y. Y is like saying my last name is Johns, and y squared is like saying my last name is Johnson. They're different. They're not the same. So y's have to only be combined with y's, and y squareds can only be combined with y squareds. So let's write an example over here at the top. 5a plus 2 plus 3a plus 4b squared plus 6 minus 3b squared minus 5. So we're going to follow the notes that we just had a while ago. So number 1 tells us to draw lines in front of each plus or minus to separate the terms. So with my pencil, in front of every addition or subtraction, I'm going to draw a line. So I have a line in front of the plus 2, in front of the plus sign of 3a, in front of the plus of 4b squared, in front of the plus 6, in front of the negative 3b squared, we'll talk about that in a second, and in front of negative 5. So, now with your highlighter. So using my highlighter, I'm going to start with what comes first, 5a. Well, in this problem, the A's are the last name that I'm looking for. So I'm only looking for any other letter of A. Well, I have 5A and a plus 3A. So now with my pencil, keep your highlighter out. You're going to need that color in just a second. So I'm going to write these down in the order that they appear in the problem. 5A, I need to keep the plus 3A. Okay, leave it right there. Put a box around your green. This is what we were saying was green. Next, you need to choose a different color. So the next one in my problem is a positive 2. Notice that 2 does not have a variable attached to it. So this is actually a constant. Remember, constants don't change, their values are never different. So in this one, I have to look for another constant that doesn't have a last name. When I come here, this has a last name of b squared. That's not its same family. 6, does it have a last name? No. So that means that positive 2 and positive 6, negative 3b squared. Oh, they have a last name of b squared. I can't highlight it. And then I have negative 5. It doesn't have a last name, so I can highlight it. So now I'm going to take, and I'm going to, again, write these in the same order. Positive 2, positive 6, negative 5. With my purple, or whatever color you chose, box it out. And now with our new color, we're going to go to the next one. Positive 4b squared. Well, b squared is this person's last name, or this number's last name. So I have to find other b squareds, which I have one right here. Now, if this one just said negative 3b, I could not highlight it because 4b squared and 4b are different. They are not the same. But because this has, excuse me, because this has a exponent of 2, just like this one, b squared, they're in the same family. So I'm going to highlight it. And then I'm going to write them down here on my notes in the order they appear. Positive 4b squared, negative 3b squared. And then I'm going to box around them. So for this one, I'm going to now simplify them into single terms. So I did number 2, color all the like terms the same color. We did that. Put each group of the like terms together. We did that. Now number 4 says simplify each group into one single term. So here's my first group. 5a plus 3a. So think about it. 5 apples plus 3 apples is going to give us 8 apples. So I would have 8a. In this problem, these don't have last names, but let's think about it. Positive 2. So 2 plus 6. Well, that gives me 8. Then I have 8, because I took the 2 and the 6 and I made 8. 8 minus 5. 8, take away 5, gives us 3. And that's actually a positive 3. Because we were still in the positive, because we had 8 minus 5, and that gives us 3. Remember, it in front of the number 3 or in front of any number that we don't say negative is always a positive symbol. Now for our last group over here, we have a positive 4b squared and a negative 3b squared. So let's think about it this way. So 4, you can put any object to it. We just want to make sure that we're keeping the variable. It never goes away. You can't just drop it off. So 4 minus 3 gives me 1. Keep the b squared. Now, I will tell you, in front of every variable, there is an imaginary 1, which is right here. So if you just saw the letter N, there's actually an imaginary 1 in front of it. You just don't see it. So we can say that this is a positive because, again, 4 minus 3 was 1, which is a positive. So 1b squared, or we could write it just b squared, positive b squared. So when we write our problem out, so we've taken all of these, we've combined them all together, what we could combine, and we get the answer of 8a, you keep them in the same order, plus 3 plus b squared. And that is your final answer. Now, as we continue with this lesson, we will not do any more examples today. We will work on that tomorrow. So be prepared tomorrow to do more examples like this. So in your math notebook today, now you need your glue and your scissors. So on page 68, I would like you to take and glue, now you want to glue this closer to the top. Doesn't have to be at the tippy top, but we're going to glue this closer to the top. So get your glue on there. Then you need your sheet that we had a while ago with our vocabulary on it. You can use your scissors and cut off these edges. You don't need all this. And we're going to glue these to the bottom. So these are going on the same page. Tomorrow we will do examples on page 69 for combining like terms. So now let's move to our table of contents. And we are on page 68. On 68, it's 10.3, combining like terms. And today is February the 1st, so 2-1. Oh, you don't need dates. I forgot. All right, guys and gals, that's it for today. Make sure that you have your notes glued in. Make sure that you have them in the table of contents, and we will do some examples on combining like terms tomorrow. See you later.